It's super helpful to pre-calc to know what the graph looks like. I'll do it really slow. Whoops. If you didn't do the pre-calc, I'm going to talk a little louder too because I'm not wearing my headset. If you didn't do the pre-calc graphing part, or if you copied the key, the worksheet's going to be tricky. And so will your test because I don't give you the graphs. All right, I'm going to stop you and just ask, Afnan, what does this make just because you know it?
A circle.
It does. It's circle with y-axis symmetry, correct? It would start at 0, 0, right? And it would peak at pi halves because we'd have 3 being the max. We're going to whip it around, and it does that from 0 to pi, right? At pi, it gets sucked back to the origin. So this does a full loop. If your calculator's set to go from 0 to 2 pi, you'll see it's still going when you think it's already done. You'll see the worm because it's actually tracing it twice. So there's my first one. Knowing what this makes is very helpful as well. Do you guys remember what that's going to make?
What?
It's going to have like a flattened piece of it. It won't get sucked back to the pole and make like that cusp or that the bud crack kind of thing. And it's also not going to make an inner loop because that's when this gets pulled farther because it can go negative. So you are correct. Getting that situated, I just start and do your key players. At 0, you'd be out at 2, and it's not 2x being 2. Remember, it's on the second circle is where you're going to start, right here. My next key player would be at pi over 2. What do I get when I put a pi over 2 in? 1, so I'd be right here. My next key player that I put in would be a pi. When you put in a pi, what do you get? I get another 2, right? And last up, when I put in a 3 pi halves, that'd be -1. I get 2 minus -1, which is 3. Why is it down here, just to repeat our graphing, and not up there? Because I got a 3 and I'm putting in that -3. Do you remember why? Because, yeah, it's not actually XY coordinate system. I'm on this 3 pi halves radial, and it's positive, so I walk forward along that. So just to review that. So it goes like this. You're right, it's going to kind of come up, make a little flattened head thing like that. There it is, and that one's ready to roll. It says find the area inside the circle and outside it's called a lemniscate. Go ahead and shade in what you're supposed to be finding. College Board will do it for you, but if you know, it's so much more helpful. So go ahead and shade in the part that you're going to be finding. And I need to stay in the circle and outside. So I'm going to be doing this guy. And we're only going to set it up, and then I'm going to assume that you could do it by hand if you had to, and we're going to go math 9 it. Are you comfortable with that? I don't feel like doing power reducing and arithmetic when it went well yesterday. Thanks, Luke. All right, here you go. In order for you to get inside of the region, it is actually very similar to how we did it when we did rectangular area. Remember when we had this function and we had to find the area of that stuff in there? Right? Do you remember what we had to do? Top minus bottom, right, for both of them? And what would we technically then be doing with our two functions? What did we do with them? Subtracted them, correct? You needed to find the length of this. It's very similar. So keep in mind, you're actually starting here is where we're going to start our integration. So how am I going to find that? Because I need my limits. Set them equal. So first thing that you're going to have to do is set them, and you just saw College Board gives a point for the limit. So if all you can find is the limits, at least go do that. I'm going to set 3 sine theta. This one is no calculator, by the way, equal to 2 minus sine theta, which means I'm going to be on the unit circle. If I had to guess, I'd say it's pi 6, wouldn't you? You'd probably guess it right if you graph halfway decent. I get 4 sine theta equals 2. So sine theta is a half, and it's exactly what it looks like on my graph. So even knowing how to graph it, if I was pressed for time and I had 5 minutes left and I hadn't started this FRQ, I would just guess at that sucker and say it's pi 6, and you're probably right. All right, so theta is pi over 6 is where I'm going to start. That's on this radial line, and I am going to start, and I'm going to go this way. Where do you think I'm going to stop? I would stop at this and then double. Because it kills the half off, so it makes my work easier, and this totally has very clear symmetry. So what was this at the top of the circle? This was pi over 2. So this is what I would do. I would integrate. I would do from 0 to pi over 2. I'm going to do r squared. Now here's where you have to be careful. I'm going to do the circle first. You have to. So, and then I'm going to subtract off this little piece down here. I'm going to put a check mark in it. That's not in the circle. So you actually have to, you can't, I'll show you what you have to do. You have to do the r squared for the whole big one first. You're going to go 3 sine theta quantity squared. You can call it 9 sine squared theta d theta. If that's all I did, I would have had all of this. Would you agree? I need to remove off this piece right here. So I'm just going to go minus. Now, why didn't I put a half out front? Because I'm going to be doubling it, but I kind of think you should. I would go like that. I would show all your work just so you don't miss them when you need them. So there's the 1/2 there. Then I'm going to subtract off from 0 to pi over 2. Correct? The inside one, and that would be like I'm just heading out. Again, you're not coloring left to right with rectangles. You're heading across, and you're actually doing these little circle sectors is what you're doing. So I'm going to go from there to there, and that's the bottom one. So you do 2 minus sine theta quantity squared d theta. Once I'm done with the whole thing, right, I would double it. Yes?
How would that work out? Because wouldn't you be subtracting the area of like the whole first thing minus the entire second thing if you just have minus the separate integral of 2 minus sine pi?
No, because of my limits. Yep, I'm only doing it from 0 to pi over 2. The first one gives me the whole half of the circle, right? The second piece gives me this part. I'm trying to color with. It gives me that piece, okay? But you're correct. If I went all the way around, yes. Yes?
Wouldn't you have to do it from pi over 6 to pi over 2?
Yes, sorry. That is pi over 6 to pi. That's my mistake. Thank you. Dang it, there's another day with a stupid mistake. You find them at least. You never leave with a mistake. Now, if you were doing this by hand, obviously you would kill off the halves and you didn't have to write those, right? Even if College Board says 1 for constant out front, you technically have the correct constant. You have a 1. So that's totally fine. If you had to do it by hand, though, what would you have to, we're not going to do it by hand. What would you have to do with this? Power reduce. This you'd have to FOIL, power reduce. It gets messy, it gets fairly long. So even on your worksheet, I'm going to let you stop doing some by hand. I'll tell you when, like once I go look at it. So that one's done. Let's go to the next one. This one's trickier. I actually had to blow the graph up on Desmo so you can see what happens. And that's another reason why College Board graphs them for you. So if there's something that's a little tiny on your calculator screen that you can't see, they'll blow it up and it'll be apparent. But I want you guys to go graph this because it's so helpful to know how to graph, even though they won't make you. And then shade in the part that you're supposed to be finding. And then I'll show you it on Desmo so you can actually see a nice one. You'll understand why College Board hands you the graph. I think it's cheesy and they shouldn't, but I get why they do. That should be enough time, right? Who haven't I picked on for a long time? Abby, what does the graph of this polar curve make? Yes. And start at 0, 3, right? And it comes up around, that's decent, okay? What does the graph of this one make, Sophie? The second one? Actually, they're tied, so it won't be flattened. What happens when the coefficients are tied? You get a cardioid. And to get the structure of it, if you're like, I don't know where to draw, just do the 4 key players of the cardioid. At 0, you'd be at 2. At pi halves, you'd be at 1. Wait. Yes. At pi, you'd be at 0. And at 3 pi over 2, you'd also be at 1. So you'd be along that radial. So it's going to come around like this. Boom. Boom. How many of you drew the right picture? If you didn't, it wouldn't matter AP-wise, but if you didn't for my test, I'm not going to give you the graphs of all of them. So make sure you've got a pretty detailed graph. Next up, I need to shade in the common interior. Agreed? So it's in both of them, so it should be kind of this football thing in here. I'm going to go shade it and show you what gets the reason College Board always gives you a really big, nice, clear graph. All right. This is what most kids would miss if they were handed if they weren't handed the graph. So I'm going to start from here, and I'm going to shade that, and then it goes here, and then it goes here, and I'll be getting that yellow stuff. Wouldn't you agree? Who's the outer function? Like, what am I integrating to? The first R or the second R right now? I am using the second R, so I'm doing R2, 1/2 of it squared from here to the intersection. What would you guess the intersection is, just because I have such a great graph? Pi thirds, go find it though, just verify. You should always verify, but it's gonna be pi thirds, or I would have a calculator, right? So 3 cosine theta equals 1 plus cosine theta, which means 2 cosine theta equals 1. Cosine theta is 1/2, it's gotta be at pi thirds. It's exactly where it looks like. I'm gonna draw that boundary radial, and I'm gonna shade all of that in. Did I hit all of the yellow stuff? Do you see how there's that little sliver that I didn't hit? Most kids would miss that, don't you think? Because your graphs are tiny. On your calculator, you can't see it. On Desmos, when they're actually, it's very clear that I am totally missing this whole chunk when I end there. Do you see it? I'm missing this whole, I guess what would that shape be? Banana kind of shape over there. So when I integrate, here's what you're going to need to do. You're going to need to go, can I put it on here? No, let's go back to the notes. This is the last thing I'm going to do today. I will do 1/2, the integral from 0 to where? Pi thirds. That will give me all of the blue stuff. I have to make sure I head out to the right polar curve. This is the second one. 1 plus cosine theta d theta. I purposely made a mistake right now. Yes, they say the half and the squaring is the most missed. So I'm going to square that. Keep in mind, though, that only gets me the blue. So what should I do with it to get all of the yellow right now? I would double it so you can get that as well. Just going like that actually got me almost all the area. This is what most kids would say the answer is, because they wouldn't see the sliver. So then, right, I'm going to do the little sliver. And I'm going to now be on the cardioid. Do you agree with me? So I have to go from the intersection pi over 3 to where the cardioid got sucked back into the pole. When did that happen? It's exactly where it looks like it happened. But if you understand the graph of it, it makes the limit so easy, right? Where am I going to integrate from for my little sliver? Pi over 3, right? To pi, right? 1/2, but now what goes in my integrand? I'm now hitting, where am I? Whoa. I'm trying to get the sliver, correct? So you're now not on the circle anymore, you're on the cardioid. So you would do 1 plus cosine theta quantity squared d theta. What's wrong with mine? What's wrong with mine? What'd you say?
No, it needs to be 3 cosine theta squared.
Oh, you're right. Sorry, I'm in the wrong one. 3 cosine theta squared. Boy, I'm really butchering. That's okay. I purposely made the other mistake, though. I've got one I made on purpose. What's wrong with it? Well, that wasn't on purpose. Why wouldn't the top limit be pi over 2? At pi over 2, oh, it is pi over 2. Yeah. You guys, I'm butchering it. Now the mistake I really intended to make. What's my mistake that I did on purpose? I did one on purpose because it's super common. I didn't double the second one. Either put it in here. I always suggest you just throw it out like that and make sure you bracket it. This I will allow you to math 9. You would never have to do power reducing on the AP exam anyway. I want you to know how, right? But you wouldn't have to. We're going to quit. I'm going to have you take out your assignment. I'm going to tell you how far. I'm going to check that you got through number 6 because I told you would. It'll just be 6 points. If you got to number 3, I'll give you 3 out of 6. I'll walk around and do that in a second. I'm going to tell you how far you should work. Actually, You have enough now to do it all, but I am going to give you a work day on this because the FRQs take a while. I'll look on my schedule when that is. Maybe tomorrow I'm just going to check that you've done 9 through 12. And let's say once you're done with 10, you can start math 9ing from there on out. All right? So 9 and go ahead and write calculator active by number 11, and we won't do them by hand after. There is one on the test you have to do all by hand, so I want to make sure we're good with that.
Which ones are
9 and 10, let's do it all without touching the calculator. 11 and 12, from there on out, I'll allow you to use your calculator, unless it's an FRQ and it says no calculator. All right? But you can use your calculator for any and all things once you get past number 10. The full key is posted, but so you don't have to log in. I'll put the answers to those 4 up here and you can see them. What else was I going to tell you? I'm going to show you the schedule so you know when it's due. All right. That was short notes. It was only 15 minutes. Usually this is longer. If you're not getting the right answers, tell me and I'll do a few more examples. BC. All right. Let's look at the schedule so I can give you a... Tomorrow is, we're going to do the 2014 FRQ for the first 15 minutes. It's one where there's intersections. We'll see how we do again. I know it's up here and you can go look. I don't want you to. I really want you doing it on the fly. You're going to have a work day tomorrow on number 9 and the review packet. What's the review packet? I gave you the big test one because there's a ton in there. Number 9 will be due then on Friday. So if I didn't tell you that already, go put due Friday. Friday we will be doing one last FRQ. I'll give you number 10. We get to work on the packet. And then Monday and Tuesday I work on the packet. When does your test start? Wednesday. We're pretty much done. There's just a couple details. Let's go see how number 9 goes. I'm a little worried I went too fast. And I made a lot of mistakes, but you caught them.